Welcome to another PSC video where we are going to discuss a problem named college event and the CR. So now let's move to the description part. Here, Himanshu, the CR of class, wants to spread some news about an event to every group of students of the college. He will have to miss Professor DK classes to spread the news to every student. So he came up with a plan. Instead of meeting every student in person, he decided to meet few people such that the person to whom he passes the news will spread it to all his friends in a group, and those friends will pass it to the other friends and so on. Okay. So your task is to find minimum number of person he need to meet to spread the news of the event. Okay. So basically what the question is saying, okay, what the question is saying is, let's say there is a class which have many students. Okay. Let's say n students. Okay. So in the question it is saying, if I were to spread some piece of information to the whole class, then I have two ways. Okay. I mean, these circles are nothing but the students of the class. Okay. Either I go to each and every student and share the information. This person, then this person, and this person. Okay. Separately. I think I marked it a bit wrong. Okay. There's a class CR. Okay. Who will need to go to each person. So that will be very time taking. Huh? In that way, the CI would have to miss some professor's class also. Okay. So another way that is suggested in the question is that, and that way is like, if there is CR, okay, and there are some people, okay, who are friends with other people, okay. Let's say this person, let me mark these now. 1 2 3 4 5 6, there's student numbers 7 8 9 10 11 12 13 14 15 16 17 18. Okay, to my numbers. Okay, so there's another approach which says that if some person, let's say these people, 1 and 2 are friends with each other. Okay, 2 and 3 are friends with each other. 2 and 8 are friends with each other. Okay, 1 and 7 are friends with each other. 7 13 are friends with each other. 13 and 8 are friends with each other, and 14 and 8 are friends with each other, and 8 and 9 are friends with each other. Okay, so in the approach it is saying, if this is a group of friends, okay, this is a friend circle, okay, where these people are friends with each other, then what the CR needs to do is he just need to tell any one of person, any one of these friends. Okay, I mean any person among these friends. Okay, and what will happen then? Let's say if CR told the piece of information to the person numbered 1, okay, this person, then what will happen? 1 will tell to 2, 1 will tell to 7 also, tell 7 also. 7 will pass on this information to 13, 13 will to 8 second, because either 8 can get the information either from 2 or 13 also, both doesn't matter. Okay, because they are friends with each other. So 2 will pass on to 3. So in this way, the CR only need this person. Na? I mean, any one of them in this whole group, he needs any one of the person. So in a particular group, he needs one person. Similarly, if I were to say these people 4, 10, 15, 5, 16, okay, these people are another group of friends, okay. So what will happen is this CR will pick any one of the person of this group and tell it. And if let's say these people, these people are friends with each other, okay, then CR would have to pick any one person among these and pass the information or tell them, and they will just pass it among their group. Now this person is here alone. There can be many person alone also, okay. It does not, I mean, it's not necessary that only one person will be alone, because there are cases where people are not friends with anyone also. So let's say this person is not friends with anyone. So what will happen then? Then CI will personally go to him and tell him, though here it won't be very efficient, but still he needs to cover all his data so that they can know what information was required to spread. Okay. So in this way, what is happening is, previously in the previous approach, how many people did we have to tell to spread the information? Here on the page 1 to 18, approach 1, 1 to 18, I would have to tell. So it was, okay, let's not go in the complexity first. Okay, 1 to 18. And in approach number 2, what will happen? Number of groups. A group can contain minimum of one person, okay, which is basically 1, 2, 3, and 4. So isn't it efficient way or not? Yes, correct. So in this way, the CI would have to tell minimum person, and that way he won't have to miss some professor's class. Okay. So now, just because I have shown you how to represent the whole information in this visual form, then you must be recognizing, or can say recollecting, some other thing also by looking at this diagram, correct? Isn't it looking like some graph? Yes or no? Yeah. This arrangement can be visualized as a graph also. This arrangement can be sorry, can be visualized as a graph. You'll say why? Then I'll say why not? Because what a graph have, the two basic components of graph is what are those? They are nodes and edges. So here, what we can say from this diagram, if we can consider all these people as the nodes, and we can show the relationship between them as they are friends with each other. So we can connect these nodes with each other only if they have a friendship connection, a relationship. That will be okay, right? So that way, nodes can represent person or student, and edges represent They represent friendship. Okay. So in that way, we can just say that this is a complete graph structure. Okay. Let me add this. This way we can visualize the problem in the form of graph. Yes or no? Correct. Now let's move on to the other part. Okay. Let's see what inputs are given in the question. Okay. In the input, it is saying first line of input is the number of test cases. Okay. Followed by n, the number of students in the class. Okay. And for that, you need to mark them as, if the number of students given is n, then you need to mark them as 0 to n minus 1. Okay. And the next line will contain e, the number of friends description. Okay. Or you can call the edges, because friends description is nothing but showing that who are friends with whom. Okay. So that in itself shows a relationship. And what we just did on the previous page was that friendship relationship will be shown by the edges. Okay. So the next line e contains, I mean, if e is given now, means there are e friendship descriptions. So the next e lines will just describe about that descriptions, and that those descriptions will be given in form of a b pairing, which denotes a is friends with b, and if a is friends with b, then b is a friend with a also. Okay. Now keeping these points in mind, let's go to the sample input. Let me copy this. Though here there are two test cases given, let me take one by one. Okay. So I am first going here. Here 4 is n, number of total students, which is 4. Okay. So let's say first given part, n is equals to 4. Okay. E, what was that? E is given 2. Okay. And E is given, sorry, E must be 2 now. Yeah. So now E must be given in AB pairing. So what are those AB pairings? 0, 1 and 1, 2. Okay. 0, 1, 1 and 2. Okay. This is the zero, 1 and 1, 2. Okay. So now, because in the question it is given that if n is equals to something now, then the markings you can give to student is 0 to n minus 1. Then what will be our students list? 1, 0, 1, 2 and 3. Yes or no? Yes, because that's given the question. So now let's make the graph. How are we going to make our graph? That will be like this. First, make our students. Okay. 4 students are there. 1, 2, 3. Now label them. Student number 0, 1, 2 and 3. Okay. Now let's mark the relationships. I mean the friendship. Who is the friends with whom? 0 is friends with 1. And there must be an edge. 1 is friends with 2. Then there must be an edge. So now tell me, or think about this. How many groups do we have? We have exactly 2 groups now. 3 can be another group also, because a group needs to be have at least a 1 student. Okay. There is another group. Now the CR needs how many students the CR needs? Anyone from this group and anyone from this group. Though the third student is alone, but still CR needs it. So total number of students needed will be equals to 2. Correct? Let's see the answer now. For test case number 1, the output is 2. Yeah, we are correct. Now let's see test case number 2. Okay, let me write it here also now. Test case number 1. Test case number 1. It is sorry, and next page will be test case number 2. Okay. Now what are you going to do? First, write the givens. For test case number 2, n is 3 and e is 0. Okay. Because e is 0, so a and b will be empty because there is no friendship descriptions. Okay. Now let me put the list of students 0, 1, 2. Okay. Because n is 3, so student can be 0, 2 and minus 1, which is 0, 1, 2 only. E is 0. So now let's make our notes first. Number of students 1, 2, 3. Now let's put the indexes. I will marking identification number, you can say 0, 1 and 2. Okay. Now let's put the relationships. Okay, if they are friends or not. Because E is 0, we have no relationships. So what will happen? The thing happen will be the total number of groups will be this one, this one. Okay, let me mark this with another color. This one, and the group will be this one. So the total number of groups that CR needs to pass on the information to will be 1, 2, 3. So total number of students needed equals to 3. Let's see the answer now. The answer is 3. Okay. Yeah. So we have understood the question and we have understood the approach, how to find a solution, and we have just found out that with our approach we can reach to the correct answer. Okay. Now the question is how to find these groups. Correct? What is the question? Question is how to find these friends groups. What should the answer? Think about it. This is some concept you have already learned in graph theory. Okay. See here. In a group, the basic information you can extract from here is a group is called a group when all the nodes in a group are connected with each other and a group have at least a one node. Okay, so 3, it does not need to reach anywhere. Okay, it is reachable from itself. Okay, so that's not a problem. But in here in this group, 0, 1 and 2 are connected with each other. Okay, so either if I'm at 0, I can reach 0. Okay, if I'm at 0, I can reach 1. I can reach 2 also. How? By going through 1, because 2 is 1's friend. Okay, that's how we are passing the information also now. Okay, similarly, 2 from 2 we can reach 1 and we can reach 0 also. Okay, so in the group, कंडीशन क्या है? In the group, every node is reachable from each other. Okay. So now what is that concept called? Concept, or can say algorithm, or whatever, say algo, or whatever name. You must have heard, no? How does this happen? In a graph, how do you reach all the connected nodes? Answer is using depth first traversal. Okay, DFT. I'll show you how. Let's go with the previous diagram. Okay, of question 1, 2, 3, 4 nodes, which 0, 1, 2, and 3 was here, and who were connected with each other? This is a 1 and 1, 2 were connected with each other. Okay, that's what was given in the question. So now let's say I have, okay, I have a visited array which is of size n. Okay, what is n here? 4. 1, 2, 3, 4. And 7 index is 0, 1, 2, 3. Okay, and how do we store a graph? You can store it in either adjacency list or adjacency matrix. I am going to use the show the adjacency list. Okay, ADJ list. So how will it be shown? It will be shown like this. One, two, three, four. Okay, 0, 1, 2, 3. Okay, who is zero's neighbor or connected with? 1. So here 1 will be there in the list. 1 is connected with, because 0 is the friends of the 1, so 1 will be friends with 0 also. Same time, at the same time I will put 0 also here. Now an information was given, because in the edges what was given? 0, 1, 1 and 2. That's how it was given, correct? So 0, 1, we put this information like this in the adjacency list. For 1, 2, okay, so 1 is friends with 2, we'll put 2 here, and 2 is friends with 1, we'll put 1 here. 3 is friends with no one, so it will be empty. Now apply DFS or DFT on adjacency list on very first item. Okay, here if you apply here, what will happen? The depth first traversal first visit 0. Okay, mark 0 as visited. Okay, I did not tell you now. Initially put 0 everywhere, none of them are visited. Okay, that's the information we are carrying. And then when we DFS, apply DFT on adjacency list. Okay, first, I mean the zeroth index, then what will happen? Device will say, okay, zero, I have visited. So for zeroth node, it will mark one. Then it will go, okay, go to the list. It will access the list. So zero's connection is with one. And when it will go on one, first it will mark one as visited. Then it will go on is one's neighbors. So who is neighbor? It sees zero, but zero is already visited now, na? Updated. So it will move on to two. Okay. Now it will for two, it will go to two and mark two as a visited. Okay. And what will happen then? Then when it comes here, it will see who are the neighbors of two also. Who is it connected to? So 2 is connected to 1. 1 was already marked visited. And now it have no other connections to be traversed. Okay. So what will happen? It will terminate. DFT terminate here. Okay. Now, then we will check on what we will check on. We will check on ADJL of 1. But DFS, apply DFS on ADJ0 if visited 0 is not equals to 1. Okay, that was a whole case. Same with all the indexes. So now it will move on to here ADJL. After that ADJL1. What is visited of 1 here? Visited of 1 equals to 1. So it will move on. Move on to where ADJL of 2 visited to where. Then it will move on to ADJL of 3. What will happen? Visited equals to 0 है. Then again DFS1. Then DFT, sorry, it's a DFT, okay. Then DFT. So ultimately, at how many times does a DFT runs in the whole process? Okay. Then DFT again. And what will happen? It will mark this visited and look for 3 neighbors or 3 is connected to the other nodes. It is nothing, so it will terminate. Okay. And terminate. Okay. So how many times DFT is running? One time here at this point and at this point. Yes or no? D and D. That's a DFT. That was that discussion. So how many times does DFT runs? Answer is 2 times. That is the answer. Okay. Now I hope you people have understood whole thing, how to do this. Now let me lead you to the pseudocode part. Okay. Let me write that. So you have adjacency list of size n. You have visited of size n, which was initially 0. Okay. That is just a representation. You should know how to do that in your own language. Okay. Initially, or can say initial value. Okay. And now you need to count need to count how many times DFT called. Okay, so for that, put a counter variable which is count, and the initial value should be 0. Okay, now what will happen for I equals to 0 to n minus 1? Okay, because we were counting from 0 to n minus 1. Okay, now if not of visited of I, okay, means if visited of I is equals to 0, if it is 0, then not will turn it into 1, means this condition is going to true, means that node is not visited yet. So what will happen then? We'll put count plus plus, because this time whenever a node is not visited, our DFT will be called. Okay, whenever a node is not visited. Okay, so count plus plus, and then what will happen? I'm not going to write the logic for your DFT function. Okay, do it on your own. That's all. So in this case, DFT will be called at two times for I equals to 0 and I is equals to 3. How? Try run it on your own. Dry run showed you already. Okay. Now write the code on your own for the set DFT. Okay. So here I will end the session. I hope you people got everything, got all the points. Let's meet in the session. Okay. Thank you.